All right, here we are back in 6.2. We're going to go on from what we did last time. Last time we plugged into y equals mx plus b. And the difference between last time and this time, we'll find out. But last time we always had our initial value, which was our y-intercept. Okay, these now we're going to have to do a little more work. All right, Mr. Brust's algebra packets are wicked long. Sully grabs the third packet. Brust did and notice it's 4.25 pages long. He estimates that every 4 packets, Mr. Brust makes the length increase by about a page. All right, so we have a couple things. We have packets, the number of packets, all right, and the unit for packets is packets. And then we have length, and we measure the length of these packets by pages. All right, and let's see, the first one I noticed was the third packet, and it was 4 pages. All right, now then it says Brust makes the length increase about a page every 4 packets. So 4 packets from now, it's going to be 7 packets, 11 packets, and 15. So now every 4, it goes up, oh, this should be 0.25, right? Every 4 it goes up 1 page, so this would be 5.25. This would be 6.25. This would be 7.25. All right? So let's graph this for 3 packets. So 3's here, it'd be about 4 1/4. That's 4 1/2, so 4 1/4 is right in between, right there. 7 packets is going to be 5 1/4, so 5 and a little more. 11 packets is 6 1/4. And last but not least, 15 packets is 7 1/4. Right about there. All right, so you can see we have a nice linear situation going on right here. So remember, we have to write our rule, y equals mx plus b. Our initial value, well, remember our initial value is when x is 0. We don't have that in our table this time, do we? It'd be great. Do we have a point on the y-intercept? No. All right, yeah, we could graph this and make it and try and figure it out a point, but it's just not perfect. All right, let's try and find our rate of change. Remember, that's our rise over run. So our change in y, let's see, our change in y is 1 over our change in x. Every time our change in y is 1. Over our change in x every time is 4. All right? So our rate of change is 1 over 4. So the question is, how do we go about filling in the rest of this equation? We have our rate of change. All right, so we have y equals 1/4 x. But how do I find the b? And that's what we're going to talk about the rest of the day. All right, so let's take a look. These were the steps we had last time. Notice all these steps are exactly the same as before. Find the slope. We're going to do that either on a graph or using the formula. Remember, y2 minus y1 x over x2, x1. We're going to find the y-intercept, and last time we did it by looking at the y-axis, and we're still going to do that if possible. We're going to look at any point where x equals 0. But now we have this third option. Plug known values into our equation, y equals mx plus b. Now see, what's going to happen is we're going to know a y, we're going to know an m, we're going to know an x. We're going to solve it to find our b, all right? And then we're going to plug those back in to our equation. So let's go see how that looks. All right, so let's see if we can't finish this off, all right? I'm going to do a couple of things here. First of all, I'm going to change this 1/4 to 0.25. Okay, 0.25 is the same value, and everything else in our table is decimal. All right, so let's check this out. We're going to do what we're talking about. We know we have a bunch of y's over here. All these are y's, and we have a bunch of x's. All these are x's. If you look at our formula, y equals mx plus b. Let's plug everything we know in. Do we know a y? Well, we know a bunch of them. We only have to use one of them. I'm going to use the first one. We could use any of them. So 4.25 equals, what's my m? My m is 0.25 times, what's my x? Well, when I use 4.25, my x for that was 3 plus b. So now we're going to solve, just like in a normal equation. 0.25 times 3, all right? Well, we can do 2.5 times 3, that's 0.75 plus b. Now I have to get b by itself, so I'm going to subtract 0.75 from both sides. 4.25 minus points, that's 3.50 equals b. So now we know our initial value. Our initial value is 3.5 pages. So our equation, all right, our equation is y equals 0.25x plus 3.5. And we used our points, what we knew, and our rate of change, what we knew, to find what we didn't know, which was our y-intercept. All right, we'll do just a few more of those. Before you get to that, I wanted to show you Mr. Kelly. You probably didn't know this side of Mr. Kelly, but he used to be a rapper. So check this out. Say what you will, but Mr. Kelly is awesome. Here we go. Write an equation of the line that passes through the given point and has the given slope. So let's see, I have an x, I have a y, I have an m. What's my equation? Y equals mx plus b, y equals mx plus b. Awesome. So let's plug in what I know. Y is 1, m is 2, and remember this is 2 times my x is 5, plus b. Now we solve it. 1 equals 2 times 5 is 10, plus b. Subtract 10 from both sides, and b equals negative 9. I have a b, I have an m. Plug them back into y equals mx plus b, y equals mx plus b, y equals 2x minus 9. There you have it. All right, let's try another one. Write an equation of the line that passes through the given points. Start, like always, with y equals mx plus b, y equals mx plus b. All right, so now let's see what I have. Ooh, I have an x, I have a y, I have another x, and another y. No slope. I can use my slope formula. y2, 9, minus y1, 2. x2, 4, over x1, 3. So 9 minus 2 is 7. 4 minus 3 is 1, so our slope is 7. Now I can plug it back in. Does it matter which y I use? It does not. You can use either y you want. I usually look at these and see which numbers are going to be better for me, so I use smaller numbers. So my y I'm going to use is 2. So 2 equals 7 is my slope right there. X is 3. Plus b. Now the only thing I can't do over here is I can't use the y from this point and the x from the other point. If I'm using this point, I got to use both the x and y from this point. So solve it. 2 equals 7 times 3 is 21 plus b. Subtract 21. So negative 19 equals b. So plug it into my formula. Y equals mx plus b. Y equals mx. Just kidding. It's in your head, right? Y equals 7x minus 19. All right, let's try another one. Oh, this is we have a graph. Great. You know what I love about graphs? It gives us points. Like this point is 1, 2, 3, 4, 5, 6. And 1, 2, 3. And this point here is 1, 0. And if you remember, it's wherever the wherever the cross y-axis is my intercept. Oh, that's a nasty one. That looks like a decimal or a fraction because it's not 0 and it's not 1, which would be nice, right? So we need a y, we need an m, we need an x, and we need a b. So let's see our y. I'm going to use this point because look at that, 0 is awesome. So my y is 0. My m, I could use the formula, right? Or I can just look on my graph. What's my change in y? I go up 3. What's my change in x? 1, 2, 3, 4, 5. Over 5. So my slope is 3/5. So 3/5 times what's x? X is 1 plus b. Now I solve it. 0 equals 3/5 times 1. That's a hard one. I don't know. Oh, 3/5 plus b. Subtract 3/5 from both sides. I know you guys love them fractions. 0 minus 3/5. Oh no, calculator. Oh, it's negative 3/5. Okay. Then plug it into y equals mx plus b. Y equals m. What's my m? I found my m was 3/5. X plus b. What's my b? Negative 3/5. Now I think we've talked about this, but remember, adding negative 3/5 and subtracting a positive 3/5 is the same thing. Okay? Let's try another one. Oh, application. Let's look at this application. Mr. Sullivan planted a Buckeye tree in honor of them winning the national championship. Go Buckeyes, Ohio State. After 4 years, it had grown to be 12 feet tall. After 8 years, it had grown to be 18 feet tall. Write an equation of a line. So let's get some information out of this. 4 years and 12 feet, those go together like a coordinate. 4, 12, there's a point. How about after 8 years, 18 feet? 8 years, 18 feet. Okay? So now I can do everything I need. Can I find my slope? Sure. y2 minus y1. 18 minus 12. x2 minus x1. 8 minus 4. So that's 6/4, which reduces to 3/2. So we know my m is 3/2. Plug it into our equation. What's that equation again, Mr. Kelly? Y equals mx plus b. Y equals mx plus b. Either point we can use. I'm going to use the first one because it looks like it'd be smaller number. So y is 12. Our m is 3/2. Our x is 4 plus b. I'm going to come into this part b. Sorry about that. 3/2 times 4. Well, 2 goes into 4 twice. 3 times 2 is 6. So I have 6 plus b. Subtract 6 from both sides. And 6 equals b. So my equation is y equals 3/2 x plus 6. That's part A. Now the reason equations are great to have, we can use them to figure out other things. For example, how tall was a tree when Mr. Sullivan planted it? Well, when Mr. Sullivan planted it, x was 0. You could plug 0 times 3/2, that's 0. 0 plus 6, that's 6. So it was 6 feet tall. You could find out how tall it's going to be at any length in time, okay? All right, pause the video and try these. Okay, here we go. Oh, remember these? These look awfully strange, but this is an x, this is a y. This is an x, this is a y. So I can find it, right? y2, negative 8 minus y1, negative 2. x2, 4 minus x1, negative 2. That's like adding the opposite, so that's negative 6 over adding the opposite, positive 6. So my slope is negative 1. Plug it in. I'm going to use the first point. Negative 2 equals negative 1 times negative 2 plus b. Negative times a negative is a positive. I'm going to subtract 2 from both sides. Negative 4 equals b. So my equation is y equals negative x minus 4. Remember, that's negative 1x, but do I write that 1? No. By this point of algebra 1, you really need to be on that. Still see a lot of kids writing that as a negative 1x, and it's okay, but you should get past that. All right? You should be better than that by now. Here's a mapping diagram, and we need to find it. All right? Let's take this. Here's a great thing. What's that go down? That goes down negative 2. This goes up 4, so my slope is negative 2/4, which is negative 1/2. Plug that in to y equals mx plus b. I can use anything. I'm going to use this one. See, it's not always the first one's not always nicest. So my y is 1. My m is negative 1/2. My x is 4 plus b. What's half of 4? 2. So negative half of 4 is negative 2. Add 2. And b is 3. So my formula, my equation is y equals negative 1/2 x plus 3. All right, there you have it. Now you know how to do them when you don't have the b in y equals mx plus b, y equals mx plus b. Good luck on the packet and kill that master check. Adios.